Hello, my name's Tom Purcell, consultant with Chariot Solutions. Uh, today's the speaker for this session is Angie Jones. Angie is Java champion and principal developer advocate for Applitools. Excuse me, Applitools. Did I say that right, Angie?
Yep, that's right.
Good, good. I should have asked you that before I started. Anyway, her talk today is titled QA for AI, the reality of developing an artificial world. So it looks like AI is just like us human developers. We're all impressed with ourselves until we run into the QA team. So with that, I'll hand it off to Angie. Thanks, Angie.
All right. Imagine a scenario where you walked into your favorite department store. And let's say you got a bonus at work, so you got a little extra cash in your pocket, and you see all sorts of things that look really cool. So you pick them up and you take these items into the dressing room to try them on. So the things that you like, you go ahead and place them into one pile. The things that you don't like or they don't quite fit, you put those in another pile. And the items that you're not quite sure about, they go in this third pile. Now, imagine that mirror there is actually a smart mirror, and it's been observing your decisions. So much so that now it's able to recommend to you other items in the store that it's sure you're gonna love. And those items even have little buttons on the mirror. So you can press any of those, and the sales clerk will show up at your dressing room door with those items in hand. Pretty cool, right? What's even cooler about this is that the technology to build such a system already exists today. So, my question to you is, how would you test this? And I want you to take a moment and think about it so you even know where to begin. When working on teams that are employing machine learning within their applications, I often hear the teams say something like, oh, we don't need to test this one. This is the machine learning feature. And everyone, even the testers on the team, go, oh, okay. And then they carry on with their lives, right? I don't know about you all, but I read the news and I know that these algorithms are far from perfect. And yet, for some reason, we blindly trust that these systems are this all knowing black box of perfection, right? Not long ago, a married couple applied for Apple's credit card. And while both were approved, the husband was granted a credit limit of 20 times greater than the one his wife was granted. Now, I know what you're thinking. You're like, well, I assume the husband must have better credit, must have, higher income, some other factor, right? Same thing I thought. But no, the couple, they file their taxes jointly. So on paper, their income is one and the same. So they called the customer service reps and they were told that there was absolutely no discrimination whatsoever because it was the algorithm. The Apple reps, they urged the couple to, check your individual credit scores as, they shamed the wife and insinuated that surely her credit must be bad. So the couple, they did that. They paid to get their credit scores. And lo and behold, y'all, the wife's credit score was actually higher than her husband's. So, of course, they call Apple again and they're like, hey, look, we're sure that you all aren't, intentionally discriminating here, but your algorithm is sexist. And given the factors that are considered when determining a credit limit, if anything, the woman should have been given a slightly higher limit than the man, right? So it makes absolutely zero sense for her to be given 1/20th of his credit limit. right? So the Apple reps nor their supervisors, they couldn't wrap their minds around how this advanced technology could possibly be wrong. You know, eventually the Apple employees, they got tired of arguing, you know, and they upgraded the woman to VIP status to match her husband's credit limit. So as I was reading about this fascinating story, I got to wondering, how would you test this? It seems like either Apple is like the other teams that I've seen who just skip testing of machine learning algorithms because they have this blind trust in them, or they're not testing with diversity in mind, which is why I'm always baffled when people naively ask, you know, why do we need diversity in tech? Or, you know, it's not about just giving women and minorities jobs for optics. No, it's because diverse teams build better software, period. Right. So I often see people treat machine learning as just some futuristic concept when there are many applications right now today that employ some type of artificial intelligence. Applications that we use on a daily basis, such as Netflix. Did you know that your Netflix homepage is personalized just for you? And it's driven by machine learning. So every recommended video you see on Netflix was selected by an algorithm. And 80% of what people watch is from the recommendation. So this is pretty important to Netflix's business model that they get this correct. But what does correct even mean in this sense? You know, how would you test a homepage of Netflix recommendations? Because I know myself better than anyone else, and I can't even say if any of my recommendations are correct or not. For example, on my homepage, there was a recommendation for Beyond Stranger Things. I had no clue of what this was. And so I looked it up on Google and I read that it's actually an after show to the popular Stranger Things series. And they explicitly say, don't watch Beyond Stranger Things if you haven't seen Stranger Things because it contains spoilers. Well, I've never seen Stranger Things, right? So this did seem a bit off, but how can I verify this? So again, the question is, how do you test it? I used to work at Twitter, and one area where we used machine learning was to detect and classify spam before it's even reported. So let's say that you had a tweet like this, which says, message us if you're looking to buy some followers, $2 per 1K. I think we all can agree that this is spam, but how do we know this? Is it the words that are being used? Because this one says, hey, wannabe celeb, you have a total of 2K fans. Why don't you buy some followers? Same words, but this isn't spam, right? Rude, but not spam. So how would you go about testing this? I bet that you all are familiar with IBM Watson. It's IBM's artificial intelligence engine, and it can do all sorts of things, like even make brownies. So I went to Grace Hopper conference a few years ago, and IBM had a booth there where they were giving out these brownies. And Watson had analyzed thousands of brownie recipes, and he came up with what's considered the world's best brownie. Now, being the nice person that I am, I went ahead and I tested this one for you. I said I can confirm that this algorithm works because yes, it was the best brownie that I've ever had, hands down. But it's not all funny games with brownies in Watson. Watson does more serious things too, like recommends personalized treatment plans for cancer patients. And this is done by analyzing their DNA along with millions of pages of medical literature and clinical trials. So I think that we all can agree there's not much room for error here, right? But how would you test something like this? So theoretical talks, they're cool and all, but that's not really my lane, right? I work in the trenches and I had to actually answer the question of how do we test these machine learning algorithms that we're using? And so I love to share my real world experiences with you all, if that's cool. So I had the opportunity to work on an existing project that utilized machine learning. And the product was an advertisement recommendation system. And e-commerce systems would use us to host their inventory of ads. And when they would engage with a customer, they would query our app to determine what's the best ad to show this person right now in real time. Okay, much like the advertisements that we see when we're surfing the web, they're tailored to us based on our browsing habits. This software allowed businesses to show specific product ads to their visitors based on characteristics of that person and their current context. So this type of algorithm isn't entirely new. However, what gave us the advantage over competitors was the coupling of the real-time decision making along with a learning algorithm that promised to make a business's advertisement better over time. Okay, so I was tasked with automating scenarios to verify if the learning algorithm was working as intended. And while this was exciting, it was also quite the challenge because I had no experience with this whatsoever. In fact, back then, this was my first time even hearing the term machine learning. So I'm going to share with you how I went about testing this. Now, when testing software, I'm accustomed to working on scenarios where the expected result is exact, right? For example, when working with a typical e-commerce application, if I add a product to my cart, and let's say that that product costs $20, right? If I modify the quantity of the cart, and let's say I add two more of this product or something, my expected subtotal is $60. This is exact. This is testable. This is automatable. What I quickly discovered that with machine learning, there is no exactness, right? There's a range of valid possibilities that could occur based on what the machine has already learned and how it's going to utilize that information in future decisions. So the first thing I needed to do was to learn how the algorithm learns. All right. And with that, I could determine, well, what's the range of correctness? So there was one guy on my team, and let's call him resident expert. So resident expert was responsible for the machine learning features. And I talked to resident expert to try to get some insight into what triggers the machine to learn, right? How does it learn? How does it use this information to make decisions? Now, resident expert, he's one of those tech guys who kind of talks over your head. You know the type. It may even be you. But resident expert, he hit me with like a bunch of jargon and mumbo jumbo that I didn't fully understand. So I took a deep dive into the code to try to get some clarity on how this stuff works. Now, I learned a few important things in my talks with him, as well as in reviewing the documentation. I learned that when the third-party e-commerce system wanted to show a user an ad, they would actually send an API request to us with the information about the customer's demographics. And we would then decide on the best ad and send that as a response to their system, okay? Then they would show it to their user, and if the user did engage with it, that was considered an accept. If they didn't engage with it, that was considered a reject. And they would send that information as another API request to us, just kind of letting us know what happened with that ad. Did they accept it or did they not? Okay. Now, before using our system, of course, it hasn't learned anything just yet. So it's just going to randomly send ads, randomly recommend ads. And then as we get more information about the types of folks who are accepting or rejecting, the system begins learning on this, right? So more and more interactions are better up until a certain point, because then we can, it's not just kind of anecdotal, we can learn more about these different patterns, right? So one or two little interactions, that's not enough to observe the pattern. You need like thousands of these in order to be able to learn effectively. Now, what the system learns is then stored in models. And models are little knowledge bases of information, right? And our system would consult these models in order to make decisions or recommendations. All right. So great. This gave me a lot to work with. So before testing any of the learning, I had to give the system something to learn, right? So I started with a very simple scenario where I wanted the system to learn that women are more likely to buy dresses and men are more likely to buy pants. Okay. Now, remember that we need quite a number of interactions for the system to observe a pattern. So I wrote a script that simulated 2,000 API requests, and each request was for a unique customer who identified as either male or female. And I randomly generated the gender of each customer. So there was always between like a 48 to 50% split of one customer gender versus the other. And my goal was for the vast majority of women to buy a dress after being shown a dress ad, and the vast majority of men to buy the pants after being provided with that ad. Now, I didn't limit the inventory to just the dress and the pants, but instead I had 5 ads: the dress, the pants, and then 3 other clothing items. Now, since there were 5 ads, the chance of a woman being shown the dress ad or a man being shown the pants ad was 20%, right? Because remember, the system doesn't know anything yet. So there are no models, and it's just randomly showing ads for a while. So if there are 5 of them, each of them have about 20% chance. Okay. To make this scenario a little bit more realistic, I skewed the conversions a bit so that it was more like a 65% conversion rate versus 100% conversion, versus like 100% of women buying dresses and 100% of men buying pants. Because the last thing we need is like a system that assumes all people of a certain demographic behave the same way, right? So also to ensure that the models were created for each of the 5 ads, 2% of the time I had the customer buy the product no matter what it is, right? So no matter their gender, no matter what the product is, they just would buy it, just so models were generated for all of those. So I executed this script, and within the code, I stored the results within a data structure. And it looked something like this. It would resemble something like this, but it essentially ended up being a pool where roughly 1,000 of the customers were women, of which 202 of them were provided with an ad for a dress, as we see in this second column here. And of those 202 women, the third column shows that 133 of the women actually bought the dress. And the rest of the third column shows that a few of the women made random purchases based on the ad that they were shown. Okay. And a similar pool was generated for the men in the pants. All right. So given the training that I'd simulated, it was clear to me that the system should learn that women are likely to buy dresses, men are more likely to buy pants. And having learned this, I also expect the system to now offer dresses more often um, to the women and trousers or pants more often to the men, right? So I needed to write an assertion here, but what does more even mean, right? I wasn't quite sure. So I went to ask resident expert who also couldn't tell me what the exact answer is going to be, nor could he distinctly give me a range to expect. Now, I'm no statistician or data analysis or anything of the sort. So I resorted to using the Pox method. And the Pox method is plain old common sense. And plain old common sense tells me that if 20% of the women were shown the ad for the dress when there are no models in place, and then after the system has learned something, I expect more than 20% of the women to be shown the dress ad. And I expect the 4 other ads to be shown less than the dress ad and less than they were shown before learning, right? Likewise, similar result expected for men with the pants ad. So now that I've trained the system and there are models, I executed the script again, this time with 2,000 new unique customers. So not the same folks, right? And I captured the ads that were being shown and the purchases that were being made into a new data structure similar to the other one. And I had my code compare these 2 data captures before learning and then after. Okay. So before learning, 202 women were shown the dress ad. And after learning, 890 were shown the dress ad. So yay, the system did learn that women prefer dresses. Excellent. And then I looked at the poor guys. So 196 men saw the pants ad before the system learned anything. And after the system was trained, only 59 saw the pants ad. So less than before. But not only that, it seems that 874 men were shown the dress ad, even though only 3 men had actually purchased the dress after seeing the ad. So now I'm really confused, right? Something's clearly wrong here. And of course, I began wondering, what did I do wrong? You know, being a novice to machine learning and all, I was sure that it was my fault, you know? So I started questioning myself. Did I not train the system properly? Maybe. So I cleared all the models that the system had stored and I basically erased everything that the system had learned and I reran this test. And this time I did get a different result. The men were now being shown the pants more often after the system learned, so yay, but now so were the women. So this is very, very strange, right? So I'm mumbling to myself that I clearly don't know what I'm doing. I don't know why they have me working on this machine learning stuff anyway, right? So I look through my code. I'm line by line at this point. I'm trying to find my error. I'm remembering the things that I learned about how machine learning works. And I do remember, you know, sometimes it needs more data to be able to capture a pattern, to observe a pattern. So I increased the number of API calls. So instead of 2,000 unique customers, I cranked that bad boy up to 10,000, right? Maybe I just didn't give it enough info. So I did that, same result. It would flip-flop. Sometimes the dress was offered the most, sometimes it was the pants. So I printed out the results of my data structures before and after learning so I can compare it, you know, for myself. And aha, remember I was randomly generating the gender, right? So it was never like 50% men and 50% women. It could be like 49-51 or something like that. So I noticed that whichever ad led to the most conversions during that training period, this would be the product that the system learned was most favorable, right? And the second most favorable one would be shown more than the random 20% of the time, but still less than the most popular ad. So it became clear to me that the customer demographic was not being considered in these decisions. And that's a clear bug. A bug in machine learning, you say? Yes, a bug, friends. Your girl Angie found a bug in machine learning. Now, writing up this bug report was unlike any bug I've ever written, right? I'm used to a little description of the scenario, a one-liner stating, here's the expected result, another line, here's the actual result. And if I'm feeling very generous that day, I might throw in some logs and some screenshots. But with this one, there was no one line expected result, right? I had to basically write like a doggone book, a research paper felt like, including like the detailed information on my scenario. How did I train the system to support this scenario? Why were my expectations what they were? And how did I go about verifying these expectations? So this book, it took me hours to write this up. And, I opened it at the highest severity because machine learning doesn't work, right? So I submitted this bug and resident expert sees it. And he takes a look and he's like, well, it works on my machine. Can you believe this? And he closed the bug report. So I was crushed. um I again got to doubting myself. I don't know anything about this machine learning stuff. I thought for sure I had found a bug, but clearly I don't know what I'm doing in over my head here. Yeah. So I humbled myself a bit. I walked over to his desk and I said, great, it's working for you. Can you show me the setup? I probably did something wrong. And he goes, well, and he proceeds to talking about, all of this theory around machine learning. And he's throwing out all of these fancy jargon, as he always does. And he never showed me any setup. He just attempted to assure me that learning is working just fine. And he knows this. So at this point, I had enough of this day and I go home, but I could barely sleep that night for thinking about this bug and what could have possibly gone wrong. So I went back to work the next day and, fresh eyes and all of that. I revisit the code again. So I did the same thing that I did the day before. Delete all the models, right? I want to start over. Look at every line of the code. I'm increasing, decreasing the number of customers. No matter what I did, the system did not learn based on demographics. So at this point, I call my team lead over and I give him, my whiny rant about how nothing is working and I'm sure it's all me and I'm doing it wrong and I don't know why you assigned me to this project. Anyway, right? So he goes, Angie, stop it. You're not wrong here. You've done the research, you've done the work, this just as well as anyone else here at this point. It's a bug. So I reopened the bug report. Now, resident expert, he sees that I reopened it. He didn't close it this time, but he did make some comments with, all of his theory and his fancy jargon and, basically said that it works. I simply replied, it doesn't. So the bug just sat there for weeks until it came time to release the service. Well, you can't release with the highest severity bugs open. So we had to address this. So the product owner called a meeting with resident expert and myself. And the meeting went something like this. So resident expert, he began to, mesmerize the room with his fancy talk. And let me tell you, when this guy speaks, people listen. He sounds very, very smart. He's throwing around these fancy words and this high-tech jargon. And, it basically summed up to blah, 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 learning works. Then it was my turn and I had to plead my case. Well, I knew that I didn't have a shot in hell at matching his wit when it came to this topic. So I took a different approach. And I said, okay, here's what's going on. Let's say an e-commerce business buys our service. They have a website and they're asking us for recommendations to provide to their people. So we're providing them these recommendations. Now, the men on their site are buying the pants like hotcakes with a 65% conversion rate. And as we're observing this, we decide it would be a fantastic idea to instead show the new guys who are coming in this site, the dress ad over and over again, even though we know that this has less than a 2% conversion rate. So by using our service, this e-commerce business is losing a ton of money, and I'm sure they'll end up ditching us when they realize this. But hey, do what you want. You got to hit them with a smile, So all of a sudden, I had everyone's attention. Product owner immediately turns to resident expert and say, run Angie scenario on your machine, like right now. Okay. So resident expert, tap, tap, tap. And guess what? It doesn't work, right? So he turns red in the face and he holds his head in shame and he says, I don't know why I doubted Angie in the first place. And I'll admit, that felt pretty good. So what did I learn from all of this? Well, in this case, hard rules such as, the exact results must be known in order to test this, which is something that I grew up on, these rules, they have to be revisited. They have to be challenged in the context of AI. And I feel like this is where a lot of the teams go wrong. They aren't really considering that, hey, yeah, it's necessary to test these algorithms, right? The techniques that you use to check to see if your button works, that's not gonna fly here, right? But that doesn't mean that you get to skip testing this stuff. Yep, testing is going to be more rigorous, but that's the cost of utilizing such software, all right? I also learned that the need for automation became much more apparent as, I had thousands of customer transactions needed to be simulated and analyzed. So if I were to sniff test this, that the app is working the way it's supposed to work, that's not going to work with machine learning. Little basic unit tests, that's not enough, right? So my test code was pretty complex, but it was able to detect this major bug and save us from embarrassing ourselves in the market, I also learned that simply knowing how to code is not enough. Resident expert knew how to code, and he was an expert in machine learning, yet he was ready to ship this software with the most basic scenario not working, right? So there is a real need for thoughtful and critical testing of these applications. If you're going to utilize machine learning in your apps, you better well start learning how to test them as well, okay? And finally, no matter how smart the machines become, having blind faith in them is just not a good look, okay? Plain old common sense can still trump an algorithm. And I used common sense to get the product owner to get past the lure of resident experts' fancy jargon. Yeah. The married couple with the Apple Card, they used common sense to convince Apple that their algorithm was being sexist. You know, while it's fine to embrace new technology, we should do that. It's imperative that we, as engineers, not allow others to convince us that any software has advanced beyond the point of needing testing, right? We have to continue to question, to interrogate, and to advocate for the human customers that we serve. Now, this was just one example of machine learning in action. If we would have shipped this as is, the worst thing that would have happened is we would lose some money, right? Maybe go out of business. In business, that seems like a big deal. That's major, right? But we're using AI for much more, where it's literally life and death. Okay. So I went to OSCON a few years ago and I heard Paul Funwick speak about the trolley problem. And I love how colorful Paul is. And so instead of me doing this in injustice, I'm just going to let Paul speak. Let's see if I can get to it. Yeah.
As you all know, for anyone who has read anything about autonomous vehicles or spoken about autonomous vehicles, it is required by law that if you are going to give a talk about one of these things, you have to mention this thing called the trolley problem. So I'm going to get that out of the way right at the start. So I want you to imagine that autonomous vehicles are real. And it's really interesting because 2 years ago when I gave this talk, people were like, oh yeah, they might happen, they might not. People would keep telling me that autonomous vehicles would be a long time coming. Now we're starting to see them on the actual roads. So I want you to think that forward into the future. Imagine that you have really smart autonomous vehicles and you have this situation. You have a cliff face with a single lane that's been carved out of it, and you have a car with an occupant, there are no longer any drivers, who was in that vehicle driving along the cliff face. And there's no place to swerve, there's only one single lane. And quite unexpectedly, a child runs out into the middle of the road chasing a ball and trips. And the car is driving at such a speed that it is unable to stop in time to avoid a fatal collision. Now, if you're wondering how could this possibly happen, the child forgot to carry their personal tracking device. So the car was not aware that they were around the corner and they were hiding behind some sort of terrain. They were behind a rock or behind a tree. The car did not see them. So the car is going to hit this child. The child will die if that happens. But the car has a choice. Rather than hitting the child, it could choose to throw itself off the cliff. And it's a long, long way down. It would be sacrificing itself and its occupants to save the life of the child. And of course, the question is, should it do this? And some people will say, yes, it should. And some people will say, no, it shouldn't. And lots of people will say, oh, gosh, that's a really hard question. How about we talk about something else? That's the most common thing I get, people telling me that, no, this is not possibly something that could ever happen. But let's pretend there is a child there. And you might say, maybe not. But what if there are 2 children in front of the car? Or what if there are 5 children in front of the car? I would hope at some point there is a sufficiently large number of children's lives at risk that you'll say, yes, the car should throw itself off the cliff. It should sacrifice itself and its occupant. So this is like the standard introduction to machine ethics, trying to convince machines to act in an ethical way. And I find this particularly interesting because we can't agree with what human ethics should look like. I have these interesting questions as to, how we should act and what is actually considered to be good. And trying to talk about a machine in this sense is really interesting.
Wow. So that my question to you is going to be what? how would you test this, right? This one isn't about math anymore. We're talking about life and death now, and it's a question of ethics. What is considered ethical is not always black and white, and we don't always agree on this as human beings. So how on earth do you go about testing this, right? There goes those politics that we all want to avoid, and at work. But as engineers, it's our responsibility to ask these questions before we blindly deliver these life impacting features. Are we killing kids or what? Um, Given a state where we need to sacrifice human life, whose life should it be? And make sure that we all understand what the system is supposed to decide. Now, let me make this a little bit easier for you, because none of us wants to even think about a child dying because of our buggy tech, right? Let's say instead of a child running out into the street, it was a deer. Hopefully, we can all agree to value human life over those of animals, right? Good, okay. But not so fast, because stuff like this happens. These algorithms can barely identify human beings. It was only a few years ago where Google Photos misclassified Black people as gorillas. Now, I don't work for Google, but my guess is that the training set wasn't diverse enough. So some engineer, good intentions, trained the system and didn't include people or enough people with darker skin. Again, this highlights the need for, diversity on these engineering teams. This seems like just a culturally insensitive goof, but when we think of this in the broader scheme of things, like in the video that we just saw, when anonymous cars have to make decisions and they're supposed to value humans over everything, we need to make sure that these algorithms can actually detect all humans. Yes, even the ones with darker skin. So in addition to ethics, there's so many other key areas that we need to be aware of as technologists when it comes to artificial intelligence. Things like security, like privacy and bias. There's so much work to do in this space. And I'm horrified to think of a world where a testing mindset isn't included in building this technology. So the future is here, my friends, and I beg of you to test it. Thank you. All right, so I'm looking in Slack for your questions. And let's see, it says, back in the 90s, I worked on something like this. We discovered that when women bought a shovel, they were more likely to buy shotgun shells. Coincidence. Also, when a man bought diapers, he was more likely to buy beer. Correlation. How do you test for coincidence versus correlation? Oh, that's an excellent question. And listen, even though I tested this stuff and I preached to you all about testing it, there's still a lot that I don't know. So I am very open to conversation with you all on how do we go about testing this kind of stuff, right? So how do you test for coincidence versus correlation? And I think that this is why it's so important to do like the distinct testing that I did, right? I didn't leave this up to chance, but in addition to that scenario, once they fixed that, I went on to do more and more types of scenarios where you can kind of fake some of that coincidence stuff and some of the correlation stuff and make sure that your system is learning appropriately, right? And you can sniff out these types of things, right? So you have to be very intentional, though. You have to think about coincidence versus correlation. Like, that's something that not all of us would just think to test for, but that's an excellent case of where we as engineers need to think outside of the feature itself and think about it in the broader context. Great question. Okay, so this reminds me of some of the testing and randomization work done in clinical trials. Are there testing tools that help with data generation of testing for ML tools? There is. There's actually like a lot of open source data as well. And that's where people get tripped up too. So you figure, okay, this is open source, it's already been trained. I don't have to worry about it. Yay, we can put this in. And then you really start seeing people say, we don't have to worry about testing it because, you know, we got it off of GitHub or whatever. But I don't like, how can we be sure how much that data was tested and if there's any issues or bias or anything in those data sets as well. So I still recommend when people use like open source data, dig around a little bit, ask some questions to the project about their testing strategy. And I don't even care what the answer is, still do your own in-house testing with your scenarios to determine like, how's it going to utilize this data? And is it utilizing it in the correct way? Like, don't just get this stuff out the box and think that it works. Okay. How do you know when you're done testing? You're never done. That's the thing with testing. There's a whole term called it continuous testing, right? That's why it's great to automate this stuff because you need to do it every time you change something, right? You're tweaking things and you need to continuously test these things. And if you have to do it as, you know, Gary, the human being who's very busy with other things, it doesn't necessarily get done, right? That's why it's important for your most valuable tests to actually be automated so that you can run them anytime you make changes to your application. Okay. Meta question. How do you test that your expectations of the results are valid? And that's a great question as well, right? Because again, I'm a human being, so that means I'm flawed. I have my own biases and things like this. That's why it's really great to collaborate with others, whether that be pairing, whether that be code reviews, the same processes that we've been using forever in software engineering. We don't get to throw those things out the way because we're using AI, which is supposed to be like this superior intelligence. Utilize those same processes, maybe even more, you know? Okay. Thank you for the great talk. I know we have a long way to go where validation of machine learning is concerned. I think we often need to ask the question, how would someone else test this? Ooh, I like that, Josh. Because if you wrote it, your perspective is not broad enough and you make assumptions that cause you not to find bugs. That's exactly right. That's exactly right. And we were talking before the talk started, and it's like, you know, when it was me and my baby, meaning my code, everything was fine. Then we let other people start poking into it, users, testers, and everything start falling apart. And it's comical because yeah, we do have you know, just the bias of I created this. I've already sniffed it. Think about Resident Expert. He very much so was convinced, no matter what I said, he was convinced that the learning worked, right? So much so that he left that bug there, and it wasn't until he was directed by, you know, management, like, no, go ahead and listen to it, recreate the scenario and make sure. But he wasn't even willing to do that because he was just so convinced. And a lot of us get like this with our code. So I do like testing, but I also do development. And I often say when I'm in pure development mode, I'm not the best tester. And I'm embarrassed to say that. Y'all don't tell nobody, to keep that between us, but I'm not the best tester of my own work, right? I'm going to test for like those happy path scenarios. I might do a little bit of, okay, error checking and stuff like that, but not as thorough as if I weren't the developer myself. And that's just being honest. Okay. Um, yeah, very true. With recommendation engines like YouTube, I know that they're designed to maximize retention on the platform. And they do this by providing videos that are similar to what you've been watching most in some way. But they also introduce a little bit of mutation into the results so that you get exposed to new content which you might like. Is it possible to create test scenarios for such subjective outcome? That's excellent. Yeah, and that's what I was trying to do a little bit with the three other products besides the dress and the ad. So I wanted to like, let's throw that out there. And in some cases, 2% of the time, people would buy those, right? So that's very, very realistic. You're always going to have some outliers, and you want to make sure that your system is able to handle those types of things. So definitely include like those kind of mutations, those outliers, those kind of boom, this is not what was expected. Because we're human beings, there's always going to be, things that we don't expect to happen. People will have demographics that we didn't necessarily expect that would buy a certain product, right? So you want to add that in the mix and make sure that your algorithm doesn't go bonkers because of that, Great question. Okay, seems to me that we should start having some standards for engines. Yeah. I agree. Not only that, and we should probably be talking about this kind of stuff more and getting some standards understanding as well as agreement around the testing of it, right? Because even like I said about the open sourced training data, given that, like if I tell you, Dave, I have this data set. I've already trained it. It's good to go. Plop it in your app. You may trust that, I did a thorough job and I didn't follow any standards. I just kind of did my own thing and winged it as the flawed human being that I am, right? So what does that even mean? Yeah, anybody can say, yeah, I tested it. We don't know what that actually means. So I agree, especially as we're using AI in, more life impacting types of software. Okay, maybe for Netflix recommendations, not that big of a deal, right? But in the things like the self-driving cars and stuff like that, or, the Watson with the cancer treatments and stuff like that. Yeah, I think there should be some additional standards in addition to the ones that are there for just typical like healthcare stuff and financial stuff, but some specialized ones for this artificial intelligence. Yeah. All right, looks like I've answered all the questions. Thank you all so very much for having me. This was a great time. I hope that you enjoyed the talk and I've given you something to think about. Okay, enjoy the rest of the conference. Take care.
Thank you, Angie. Great talk. Take care.
All righty. Thank you.
Bye.